All right, so I had a few problems that were asked for me to go over. So I'm going to go through each of these, and hopefully this will help you when it comes to your test that you're going to be taking. All right, so it says the graph of the function, and it gives you a polynomial that has a degree of 3 as a 0 and -2. What are the other zeros? So remember, zeros are x-intercepts. If they're real, we could have some imaginaries, but I always start out by graphing them just so I know exactly going in what type of zeros I'm going to have. All right, so I can clearly see that I have a 0 at -2. It crosses it, so that happens one time. But then when I look at the other ones, I can see that those don't look like they're rational numbers. So we have numbers that are most likely going to be irrational. So they're still real, but they're going to be irrational. So the best thing for us to do to figure out our exact numbers is one, I can do synthetic division and reduce this down, and then do the quadratic formula to find the exact answers. Or two, if it's multiple choice, look at my zeros and compare the answer choices to that. So I may have to figure out the decimal value of the answer choices. So looking at this problem, I have a 0 at -2. So I have k equals -2. And I have 1, -2, -7, and 2. And I'm just going to do my synthetic division here. And we do have a remainder of 0, which is what should happen. So I now have a polynomial that is a quadratic that I'm going to have to use the quadratic formula for. Now I would have to use the quadratic formula because there's no numbers that I can multiply to give me 1, but then add to give me -4. So remember the quadratic formula, a is equal to 1, b is equal to -4, and c is equal to 1. So x equals -b, so -4, plus or minus the square root of -4 squared minus 4 times 1 times 1. That's all over 2 times 1. Okay, so I need to do some simplifying here. So if I do -4 squared minus 4, so that's going to give me 12. Okay, so I have x equals 4 plus or minus the square root of 12 over 2. Now, the only thing about 12 is 12 can be reduced if I think about a factor tree, because 12, like, let's say that's 3 and 4. Well, 4 is a perfect square. So if I take the square root of 4, that's going to give me a 2 on the outside and a 3 left over on the inside over 2. Now, the only other thing that you've got to remember is to reduce. So I need to reduce 4 divided by 2 and 2 divided by 2, which is going to give me 2 plus or minus the square root of 3. But again, if it's multiple choice, then you can clearly take the answer choices that were plugged in. So like obviously they would have to give you this as one of your answer choices. So if I plug that in, that's going to give me 3.3732, which is my rounded decimal that they give me there. I could also do minus. Same thing. That is my 0 there. So you can always compare the answers that are given as well, especially if they're real. All right. So for the next one, it said simplify the following expression. So it's division. We cannot do synthetic division here because remember, in order to do synthetic, you have to have that linear binomial, that x plus or minus k. So we're going to have to do some long division. So I have x squared minus 6x plus 2 is what we're dividing by. And I have x squared minus 4x plus 40. All right, so we got to figure out, what do I need to multiply x squared by to give me x squared? Well, I mean, pretty simple. I'd multiply that by 1. So when I distribute that out, that's going to give me x squared. 1 times negative 6 is going to be negative 6x, and 1 times 2 is going to be plus 2. Subtract. That cancels, so negative 4 minus negative 6 is going to give me 2x. 40 minus 2 is going to give me plus 38. Now, the fact that at this point we now have 2x, and 2x is x is a lower degree than x squared, means that we cannot do division anymore for long division. So my answer would be 1 plus my remainder. This whole thing is my remainder because we can't divide out anymore, over the divisor. Another thing you could do is if you actually take the problem and turn it into a graph. So like you could say x squared minus 40x plus 40 divided by x squared minus 6x plus 2. The answer that you get, or the answer choices, should match that same graph. So you got to be careful when you're typing this in, though. You got to make sure that you are putting all your pieces in correctly with the numerator and the denominator. And I just realized that I made a mistake. This should be 38 instead of 8. So I'm glad I caught that because the graph was wrong. But if you look at the two graphs, the graphs are on top of each other. So I can see that regardless of the reduced divided out version, they should still be the same graph. So you can always check it that way as well. All right, so the next one, it says what must the value be substituted for k so that this, if I reduce it, or if I divide it out, it'll reduce to that problem. So it's basically, I can either, one, do synthetic division, like I could take each answer choice here and work through every single one of them as k and see which one gives me the right answer, or I can work backwards with my synthetic division. So just to kind of make sure we're noticing this, remember, in order to do synthetic division, you've got to have all of your values in order. So we do need a placeholder at x squared. And they're saying that they're dividing by x minus k. Okay, so if I set this up, this is going to be k. We don't know what k is, but I do know that this is 1, 0, negative 7, 6. I also know that when I reduce this, okay, this is going to be a 1, a 2, a negative 3. All right, and from there, I would basically work backwards. Okay, so I know that if it reduces, it didn't have a remainder, so this would be 0. So this would need to be negative 6. Okay, so then you ask yourself, what can I multiply here and negative 3 to give me negative 6? Well, that would have to be a negative 2. So, or excuse me, a positive 2. So right now we're saying that we're most likely going to be looking at a positive 2 here. Okay, so if I reduce that, so 2 times 1 is going to give me 2 here. Add that, that does give me a positive 2. And then 2 times 2 is going to be 4. Add that together, gives me negative 3. So my k value would have to be 2. So you really are starting back on this side and you're working your way backwards in order to clarify what 2 has to be. Or again, you could just check each one of them and see if they work out. All right, so given this function, they want to know what does k have to be in order for it to be a factor. Now remember, to be a factor, the remainder would have to equal 0. So I can work backwards with my synthetic division. So I know that k equals 2. So I have 1, -2, k, and 2. And we know this has to equal 0. All right, so a few things that I can go ahead and look at here. I know that this is going to be a 1. So 2 times 1 is 2, so that's going to give me 0. Well, 2 times 0 is going to be 0. Now, the only other thing is if I've also, in order for this to equal 0, this is going to have to be a -2. Okay? So how do I make this equal a -2 if I have a +2? So this has got to equal -1. So k would have to be -1 in order to add 0 and 1 right here to equal -1. So you're kind of working it from both sides, looking at the pattern. So you're doing it here, going through here, and then figuring out what these two would have to combine together to give me -1, but we knew this had to be -1 because the only way to multiply 2 and get -2 would be -1. So you're kind of working it, working the pattern from both sides on that one. All right, so write a polynomial whose functions are given below. So first thing I would do, I would be mindful of the fact for this problem is I know that I have 2 real and I have 1 imaginary. Well, remember, imaginary has to come in sets of 2, so I have to have the positive one. So I have to have a polynomial with degree 4. Okay? So that's a given. The next thing I would do is I would look at it graphically. So I have x raised to the 4th power. And I'm going to put that in so I could see my real roots. All right, so I definitely have one at -3 and +2. This one I have -2, +3, so that's not going to work. All right, and for this one, I'm going to change it here. So this needs to be -13. All right, so for this one, way up here, so that doesn't even hit the x-axis, so there's no way that can be the right answer. So back to the last one. So I have x raised to the 4th, 5x to the 3rd, 11x squared. And now I can verify that I have zeros at -2 and 3. All right, so then it's talking about maximum minimums. Now, yes, this is a topic from way back when we first started the class, but you should be able to determine maximum minimums looking at it graphically. So when I'm looking at this problem, I should see that I have a maximum here. Remember, maximum is a hill, and I have a minimum here. Remember, hill is minimum is a valley. All right, so it says that I have a relative maximum. So my maximum is at -1.53 and 12.01, which maximum A is incorrect because it says 8.3 there. C is incorrect, so we're looking between, well, actually D is wrong too because it said -1.2 for the maximum. So my minimum is 1.2 and -8.3, and that makes A, B the correct answer. So you just need to know the difference that a maximum is the hill, minimum is the valley. And multiplicity. So remember, multiplicity, if it's even, it does like the kiss with the x-axis, and if it's odd, it does that point of inflection. And then if it's single multiplicity, which means it really doesn't have multiplicity at all, then it just crosses. Okay? So it's asking about the zeros and what type of multiplicity I'm going to have. So I'm going to look at it graphically. And looking at it that way, I can see that it crosses at 3. So we have single multiplicity at positive 3. So looking at the first one, it doesn't even have 3 as a value, so that can't be right. The number 0 has 0 multiplicity at 2, and then 1 and 3 are zeros of multiplicity. So at 1, it does cross, so that's single multiplicity. However, at 0, it has even multiplicity. It has even multiplicity at 0 because it does that little kiss with the x-axis. It just touches it. It doesn't cross it. So the correct answer there will be B, because at 0, it has multiplicity 2, which is even, and then 1 and 3 have multiplicity 1, which means single. Okay? If you guys have any more questions, just let me know.